Today we're going to talk about continuity. I want to just start off by getting kind of an intuition for what it means to be continuous. So I've got a graph of a function here, and I'm going to tell you that this function is continuous. And kind of a way you can get a feel for if it's continuous is by looking at the graph. If you look at the graph and it looks like it's one solid piece without any breaks or holes or gaps, then that means it's continuous. So if we look along here, you can see that one piece, so it's continuous. Well, what are the properties that make it continuous? All right, let's look at a single point. So we're going to look at A and go up. Now, how would I know that here at A it's continuous? Well, basically, for there to be no breaks, there are two things that need to happen. First, we need to have a point, and the second thing is we need the two sides to meet up with that point. If this happens, then we know at this single point we are continuous. So you might be wondering then, what is something that's not continuous? All right. So let's draw one of those. And we'll talk about why then it's not continuous. All right. All right. So here we have a graph, and we're going to look right here at A. So what I mentioned before is that basically two things need to happen. The first is you need to have a point. So we're going to go up, and if we look here at A, right here, it looks like there's actually a hole, that there's a point missing. So this, where there's no point, would be an example of something that's not continuous. But not all graphs are going to be like this. So let's look at another way it could not be continuous. Alright, so here, again, we're just going to look right here at A. Alright, this time, if you look up, right, we have a point. So our first kind of check is done, but now we need to see, do the sides meet up? Well, if we look at this side, right, it comes around and it meets that point. But if we look at the other side, it's all the way over here. So you can see that this side and this side are not meeting up, and since they don't meet up, this one is not continuous. Alright, there's one other way a graph may not be continuous. It's something that looks like this. Alright, for this one, if we look here at A, if we go up, there's no point here. So we've already broken our first thing we need to check for continuity. And if we actually look, the sides, although they're behaving the same, they don't meet at a point. So this one really isn't continuous. Alright, so now that we've kind of talked about what continuity is and what we need to check for and what it looks like to not be continuous, let's kind of formalize our definition. Alright, so to be continuous, one, we need to have a point. At wherever we're looking, so at, let's say, x equals A. And the second thing is we need the sides to meet up at the point at x equals A. So what we're going to do in the next examples is to see how do we actually check this, especially if we're not looking at a graph.